Yes, ma'am.
Okay. Okay, ma. Today we are going to discuss about the topic transport layer. Okay. So everyone knows that. So transport layer, that is in the OSI model, that is the fourth layer, right? So fourth layer is transport layer. That is first one is physical layer. The second one is data link layer. Third one is network layer. The fourth one is transport layer, right? So the main role of the transport layer is to provide the communication services directly to the application process, okay, running on different types of hosts. So the main role is, that is, it communicate process to process communication, that is done by the transport layer, okay. So one process to another process, that is from one system to another system, source to destination, from the source one process to another source, that is in the destination another process, it communicate the data. Process to process delivery is done by the transport layer. So you can see in this diagram, transport layer, actually transport layer is kept on the in between the network layer and application layer, okay. So you can see here that is in between the network layer and application layer, the transport layer is there. So the transport layers, what are the responsibilities of transport layer? See here you can see that packetizing and addressing, connection control, reliability. Okay, these are the main responsibilities of transport layer. Okay, so apart from that, congestion control, congestion avoidance, quality of service. Okay, all these are also the features of transport layer only. Okay, see the responsibilities: packetizing, connection control, addressing, and reliability. It provides reliability. So the transport layer provides reliability of communication from source to destination. So packetizing. So everyone knows that actually the large amount of data can be transmitted from one source to destination, right? So sender to receiver. So that is the at a time we can't send the bulk amount of data. So we have to divide the large message and messages into small amount of packets. Okay, that is called packetizing. That is the large messages divided into number of slots. Okay, small packets, that is called as an packetizing. It divides the large amount message into small amount of data. Okay, that is called packets. So it then each and every packet, the header addresses will be added in that header. Connection control, actually in transport layer, that is the connection is classified into two types. One is connection oriented and delivery, and another one is connectionless delivery. Okay, so connection oriented delivery means that is the path is fixed from the sender to receiver. Okay, that is for a best example is telephone system, that is the landline phone. So everyone knows about the landline phone, right? So the telephone system, in the telephone system the path is fixed. That means, so the sender and sender to receiver, which path it has to take to transmit the data. So that is fixed in the fixed in this connection oriented delivery. Okay, so connectionless delivery, that is connectionless oriented delivery means that is the path is not fixed. So it can choose any path. Okay, it can choose any path to transmit the data from sender to receiver. Okay, that is called connectionless delivery. So connectionless delivery example is, so nowadays we are using mobile, right? Mobile laptops and also. So you can that is a mobile. In that mobile connectionless delivery is used. That means, so number of paths will be there. So which path is free, that path can be taken to transmit the data from sender to receiver. That is called connectionless delivery. But connection oriented, if the path is free, okay, whether the path is free or not, okay, it doesn't matter that if it is free also, which path is assigned to the particular node, that path should be, if the path is busy also, it has to wait. After that the free, then it can transmit the data from sender to receiver. That is called connection oriented. So connection less oriented, if which path is free, that is any path can be taken by the node to transmit the data. That is the number of the packets may be divided into number of data can be divided into number of packets. So the each and every packet contains the packet ID, right? So packet ID 1, packet ID 2, packet ID 3, so like that. So any number, how many number of packets are there? All the number of packets has the ID, right? So based on the ID, it can finally at the receiver side, it will be reassemble the data in the connectionless oriented delivery. Okay. Next up, addressing, that is called connection control. So in the connection control, two classifications are there. One is connection oriented delivery and another one is connectionless oriented delivery. Next one, addressing. So addressing means, so logical addressing. So logical address, actually in the network layer itself, logical address will be assigned, right? So that in transport layer, one more address is assigned here. That is server, that is port number, port address. Okay. So port address. So port address means one of the important address which is used in the transport layer. So it is the logical address of each application or process. Okay. So I told you that is mainly the process to process delivery will be done in this transport layer, right? So for that process to process delivery, process to process communication, we need one more address that is called as a port address. Okay, that is called port number or port address. Okay, so the port ID is the logical address of each application or process that uses the network or the internet to communicate. Okay, so a port number uniquely identifies the network based application in the computer. Okay, so each program is allocated 16-bit integer port number. Each application or program is allocated a 16-bit integer port number. So everyone should know that the process to process communication, we need the address that is called port address. Okay, so that port address is used in the transport layer. So in network layer, logical address will be assigned. In the data link layer, MAC address is assigned, right? So in
Hello, ma'am. Ma'am, your voice is not audible, ma'am.
okay, can you hear me?
Yes, ma'am.
Now,
Yes, ma'am. Visible, ma'am.
can you, okay, okay, okay. Okay, next, transport layer responsibilities. Now we have discussed, that is process to process delivery and end-to-end connection between host, multiplexing and demultiplexing, connection establishment, congestion control, flow control, error control, data integrity. So all these are the responsibilities of transport layer. So we can see here, that is in this diagram, the process to process communication. Okay, in this diagram we can see here, actually one sender is there and one receiver is there, right? So this is the sender, one sender, receiver. So two nodes there. In the sender, you can see that, so in sender, so many processes may be running in the sender, right? In one system, you may use one system. It may be a laptop or it may be a system, whatever it may be. So in that system, you are that is, so many processes may be running at the same time. So you may download the files, you may hear music, you may take a printout, you may watch movie. So many processes can be running in the at a time in the system. So at the same time, at the receiver side also, you can see that in the sender process, so many processes are there. So in the receiver side also, so many processes are running in the same system. So we out of so many process, which process is activated? Okay. So in which process it has to deliver the data? Okay. So that will be done by this port address. Okay. So by using port address, the process to process communication is done in this transport layer. Okay. So here in this diagram, you can see that node to node delivery, right? Node to node means actually that will be done in this data link layer. From one node to another node, it just pass the message. Then that node will pass the message to the nearby node. Like that, the data will be transmitted from one node to another node. That is called that is nearby node. It passes the message. That's all. Okay. Source to not source to destination. One node to another node. Okay. It may be a router. It may be a hub, or it may be a switch. It may be a router. It may be a system. Whatever it may be. Nearby node, it passes the message. Okay. That is called node to node delivery. So that is done in this data. Then network layer. So you can see in this diagram, node to node delivery. Next to host delivery. That is end-to-end delivery, end-to-end communication. So source to destination delivery. Okay. So source to destination delivery means that is the sender send the message to the receiver. Okay. That is exactly the receiver has to receive the message. That will be done in the network layer. The sender, the source has to send the message to the destination. So in the proper address, it has to hand over the message. That is the responsibility of network layer. Okay. So sender has to send the message at the correct destination, correct address. That will be done at the network layer. That is called host to host delivery or end-to-end communication. Now, next layer, that is the transport layer. In the source to destination delivery, the source so many processes may be running at the same time, and the receiver also the so many processes may be running at the same time, right? So out of so many processes, which process it has to hand over the message? Okay, that will be done in this transport layer by using the port address. So now I think all of you are clear about process to process delivery. That is the main aim of the transport layer. Okay. Next up, so port address. Okay, so already told you what is port address. That is, a port address is the logical address of each application or process that uses a network or the internet to communicate. Okay. Know about that port address. Next, in this port address, actually port address range is that is 16. Actually, port address size is 16-bit. The range of port address is 0 to 65,535. 0 to 65,535. That is the range of address. Okay, range of address. So in that I told you already, that is the data layer, that is MAC address is assigned, and network layer IP address is assigned. This is a logical address, and transport layer, that is port address is assigned. Okay, that is the range is port address range is 0 to 65,535. Okay, so in the actually IP address versus port number. Everyone knows that IP address, that is IP address versus number. So IP address is mainly used the network layer, and port address is mainly used the transport layer. So IP address mainly used for sender to destination delivery. Here, that is process to process communication. We are using this port address. Okay. Next, port number. Actually, that is IANA, that is Internet Assigned Number Authority. Okay, this in the we can say that is Internet Corporation for Assigned Names and Numbers. Okay, but the same only. So that is the association use this range. That is the port numbers actually divided into three ranges. Okay, so I told you 60 up to 65,035, right? So here the first three parts, it is divided into three categories. The first one is well-known ports, that is 0 to 1023. Okay, 0 to 1023. Next is registered ports. Okay, ports ranging from 1024 to 49,151. Okay, actually these registered ports are assigned or controlled by IANA. Actually, IANA mainly controlled the first category, that is well-known ports 0 to 1023. But registered ports, only it is registered or assigned, but it is not controlled by IANA. That is the range from 1024 to 49,151. Okay, it's are not assigned or controlled by IANA. It is only registered with IANA to prevent the duplication. Okay, so it is mainly used to prevent the duplication. Next, dynamic ports. That is the next third category. Dynamic ports. Actually, ports ranging from 49,152. Okay, the next range, remaining category, that is the remaining range values, 49,152 to 65,535 are neither controlled nor registered. Okay, so it is not also neither controlled or not registered. So it can be used by any process. It can be used by any process. Okay, so these are the three categories of port address. So the port addresses are mainly divided into three categories: well-known ports, registered ports, dynamic ports. So port that is well-known ports means 0 to 1023. Registered ports, that is the ports ranging from 1024 to 49,051, and dynamic port, that is ports the remaining value 49,152 to 65,535. So these range only in this diagram. That is, you can see the first category 0 to 1023, then the registered, next dynamic. Okay, so three categories are shown in this diagram. You can see that. Okay, well-known, registered, and dynamic are private. Next, that socket address is also used in this layer. That is the address, that is combination of IP address and a port number. Okay, so socket address you can see in this diagram. So IP address, port number. Okay, so mainly it is used to that is connect the client and server. Okay, so combination of IP address and port number, which these two address together is called as a socket address. Okay, so client socket address defines the client process unique. Okay, just as a server socket addresses defines the server process uniquely. So client socket address and unique, server socket address, both are there. Okay, the transport layer protocol needs a pair of socket address, that is client socket address and server socket address. Both addresses are used to connect the data, that is sender and client and server. Okay, both can be connected by using this socket address. Okay, end-to-end connection between hosts. Okay, there this end-to-end connection. So before we have discussed about that end-to-end connection between hosts means by using that in the network layer, source to destination delivery. Actually, in this transport layer, we are using two types of protocols. One is UDP, another one is TCP. Okay, so TCP is a secure connection oriented protocol. Okay, so it uses the handshake protocol to establish the connection between the two hosts. That means one source to their destination. So it that is the TCP, transmission control protocol, which is used to it is a secure connection oriented protocol. Okay, it establishes the connection between the source and destination. And the TCP also provides reliable delivery. Okay, TCP also provides the reliable delivery of message. Okay, so but actually this bulk amount of data can be transmitted by using TCP. Okay. Next, multiplexing and demultiplexing. In this diagram, you can see that there is multiplexing and demultiplexing. The first one is multiplexing, and second one is demultiplexing. So multiplexing slide is not visible.
Port number it's waiting, ma'am.
Port number only it is waiting, yeah? But actually I moved only. Right now it is my showing multiplexing and demultiplexing only. Okay, or once again I will now also is not showing.
No, ma'am.
Okay, I'll share one more time. Okay, maybe due to okay. Now you can view that diagram of multiplexing and demultiplexing.
Yes, ma'am.
Okay. So multiplexing and demultiplexing. Actually, multiplexing means that is the sender side. There may be several processes, right? So many processes may be running in the sender side or receiver side. For the sender side, there may be several processes that need to packets, right? However, there is only one transport layer protocol, that is UDP. So I told you already, that is either TCP or two protocols are there in transport layer, UDP or TCP, right? Any one of the transport layer protocol can be used for multiplexing or demultiplexing. So protocol accepts the message from different processes. Okay, these protocol accept the messages from different processes. So differentiated by their assigned port number. So after adding the header, the transport layer passes the packet to the network layer. Okay, so multiplexing means that is there may be several processes that need to send packets. So there is only one transport layer protocol, either UDP or TCP can be used for multiplexing or demultiplexing. Okay, so this protocol accept the messages from different processes and differentiated by their assigned port number. After adding the header, the transport layer passes the packet to the network layer. Next, demultiplexing. So that is opposite, that is the reciprocal of multiplexing is called as demultiplexing. Okay. At the receiver side, okay, sender side multiplexing will be done. At the receiver side, demultiplexing, that is transport layer receives data or segments from the network layer, right? So after error checking or dropping of the header, the transport layer delivers each message to the appropriate process based on number. Okay, after checking of the header, the transport layer deliver each to the appropriate process based on the port ID. Still error control. So we need to make the transport layer reliable if required by the application, right? So if error control means suppose if any problem, it detect any corrupted packets, right? So it detect and discard the corrupted packets and keep track of lost. Sometimes the packet may be lost or discarded packets, and it should be resent, right? So that is if any error is find out by this in this transport layer, it has to control the error. Okay, it has to rectify the problem. Okay, suppose it is the corrupted packets are there means if sometimes the packet may be lost, right, or they discard the packet means, so it has to resend the packet once again, right, and it has to recognize the duplicate packets also. So if any duplicate packets is there means it has to discard them, right? So for out of order packets, okay. If any out of order packets in the buffer means, okay, it has to until the missing packets arrive. Okay. So connection oriented and connection less oriented services. In the previous slide itself, I explained that is connection less oriented example is, that is the best example for connection less oriented is mobile connection oriented telephone system. So in connection less oriented, the UDP protocol is used, but connection oriented service TCP protocol is used. Okay. So TCP, UDP, two main protocols, and one more protocol, SCTP. Okay, stream control protocol is also there in this transport layer, but these are the two main protocols. So UDP is used in this connection less service, and TCP, which is used in the connection oriented service. Okay, connection service and connection oriented service. Okay, packets in connection less oriented, packets are sent from one party to another with no need for connection establishment or connection relay. That is, their No need to establish the connection between the sender and receiver. It can choose any path, okay, to transmit the data. But because packets are already given by ID, packet ID, right? Based on that ID, finally, all the packets will be assembled at the receiver side, okay? So, but in connection-less oriented service, there won't be any acknowledgement. That means no acknowledgement means, that is, if any packet sent from sender to receiver, so it won't send the receiver send an acknowledgement. I have received the packet, like it won't send an acknowledgement. Okay, so that's a sender can't identify that whether the receiver has received the packet or not. Okay, but if send the acknowledgement means, okay, then the sender can, okay, get the idea, okay, whether the receiver has received the data safely. Okay, but in connectionless service, there won't be acknowledgement, no acknowledgement. In UDP, it won't send an acknowledgement, but in TCP, that is in connection oriented, it sends an acknowledgement. Okay, so if we receive an acknowledgement, so the sender can feel that, okay, safely the data can be, the data is received by the sender. Okay, that is called connection oriented service. Next up, connection establishment and termination in TCP. Okay, connection establishment termination in TCP. So to establish a connection, actually, this diagram you can see that it is called as a three-way handshake signal. Okay, connection establishment and termination. First one, this diagram is called as a connection establishment diagram. Okay, that is, so you can see that TCP three-way handshake connection establishment. Okay, establish the connection, TCP uses the three-way handshake. That means from sender to receiver, it has to establish the connection, right? For that, it has to use three-way handshake. Before a client attempt to a connection to connect with a server, the server must bind to the listen at a port to open it up for connections. Okay, that is called passive open. Actually, it's very simple. I'll tell you that the sender has to send the single signal. Okay, the first node is called as a sender, the second one is called as a receiver. Okay, otherwise you can say that the first one is a client, the second one is a server. Okay, whatever it may be, here we are denoting that one sender, one receiver, right? So first sender sends synchronous signal to the receiver, then the receiver has to send the synchronous acknowledgement. Okay, that's for the synchronous signal. It's there is synchronous signal means actually it is active open. Okay, that is, it is ready to start to send the data. Are you ready? Like that, it send the message. Okay, performed by client sending the synchronous to the server. The client set the segment sequence number to the random value to A. Okay, synchronous signal is sent from the sender to the receiver. Then the receiver is ready to receive the data means then it send the acknowledgement signal. That is synchronous signal, acknowledgement signal. For that synchronous signal, it send the acknowledgement number. Okay. After receiving the acknowledgement, then the client, that is sender, has to send the acknowledgement. Okay. After receiving that acknowledgement from the receiver, then it is sent that acknowledgement signal. That is the third one, acknowledgement signal, that is sent by the sender. Then, okay, now the connection is established. Okay, before transmit the data, first it has to establish the connection. How it is establishing the connection, that only we have discussed in this diagram. First, before establishing the connection, first sender has to send the synchronous signal. If the receiver, that is the receiver, is ready to receive the message, then it sends an acknowledgement. Okay, if after receiving that acknowledgement from the receiver, then the sender is ready sending the sending the acknowledgement to the receiver. Okay, now that is connection is established. Once the connection is established, okay, the data will be transmitted from the source to destination. Okay, so next you can see that after, that is first in the first diagram we discussed about the connection established, right? In the second diagram we can see that is the connection. After establishing the connection, the data is transmitted, right? What are the data are there to communicate? So all the data are transmitted from the source to destination. Okay, once the transmission is over, the next thing is you have to terminate the connection. Okay, so properly you have to terminate the connection. Then only other nodes can use that resources. So now how to terminate the connection? So first sender, that is called as here denoted as initiator, receiver. Okay, send source destination. Now once finish the data transmission, then the initiator or sender has to send the finish signal. Okay, the sender has to send the finish signal. Okay, finish the transmission. Like that, it has to send the message. Now, after receiving finish signal, then the receiver has to send the acknowledgement. Okay, I'm also going to finish. Okay, like that, it has to send an acknowledgement. Okay, after receiving that acknowledgement, then after sending the acknowledgement by the receiver, then it receiver also once again receiver is also sending the finish signal. Okay, now that means the receiver is also going to finish the connection. Like that, it send the message. Now the sender after receiving the finish signal, then the receiver sender is also sending the acknowledgement signal. Okay, it's very simple. Once the data transmission is over, first is sender has to send finish signal to the receiver. Now the receiver send the acknowledgement by receiving the finish signal from the sender. After sending the acknowledgement, receiver is also sending the finish signal. That means it is going to end the connection, terminate the connection. Okay. Now after receiving that finish signal from the receiver, the sender is also sending the acknowledgement signal. Okay. Now the connection is terminated. Okay. Or connection is terminated or closed connection. So this is the way it establishes the connection and terminate the connection. Before transmitting data, first it has to establish the connection. Once the data transmission is over, then it has to terminate the connection. Okay. So just we'll briefly discuss about what is UDP, what is TCP. So UDP, actually these are the UDP and TCP, both are the two protocols, main two protocols which is used in this transport layer. So as already we have discussed about that, that is UDP is a connectionless oriented. So connectionless oriented, and it won't provide acknowledgement, right? So no acknowledgement, the UDP won't provide any acknowledgement, so that it is called as an unreliable transport protocol. It is called as an unreliable transport protocol. Actually, a small amount of data are needed to transmit, means we can use this UDP protocol. Okay, but bulk amount of data means we can prefer for TCP. Okay, so UDP is a connectionless protocol and unreliable protocol, and no flow control and error control techniques are available in UDP. Okay, but it is a convenient protocol for multimedia and multicasting applications. So multimedia multicasting applications center, we can prefer UDP. Okay, next, so you can see this diagram UDP. That is the packet format. Okay, how it send the message, packet format. That is source port, destination port, length, checksum. Okay, source port means source port ID, port address, source port ID, destination port ID. So length of the data, checksum. That is how to. That is the one of the mechanism to detect the error, checksum. Then after that, the data is kept in this part. Okay, so this is the packet format of UDP. Okay. Then in this UDP, which are the protocols are used? That is the listed in this table: port, discard, users, daytime, port, charge generator, and CASA characters, domain, boot PS, boot PC, TFTP, RPC. So these are the protocols that are used here. Okay. Next. So UDP message queue. You can see in this diagram UDP message queue. That is, port abstraction is typically implemented as a message queue. When a message arrives, the protocol appends it to the end of the queue. Okay, which data, that is, when a message arrives, it will be kept in the end of the queue. When the queue is full, okay, if the queue is full, the message will be discarded, right? Because if the queue is full, means there is no space, right? So there won't be any space to keep the data. So automatically the message will be discarded. There is no flow control that tells the sender to slow down. That is, I told you already, that is flow control, error control mechanisms are not available in UDP. Okay, so that there is as if there is no flow control and error control mechanisms are not there. So if the queue is full, also the message will be discarded, because the flow control mechanisms, that it won't indicate that, okay, that the queue is full. Okay, when an application want to receive a message, one is removed from the queue unless the queue is empty. Okay. The applications. So applications, that is mainly it is used in the multicasting and the multimedia streaming. Okay, my multicasting and multimedia streaming. Next, advantages means that is UDP requires less processing at the transmitting and receiving of host. Actually, simple to use in the network. Okay, so disadvantages, actually disadvantages of UDP means It provides unreliable services, acknowledgement. It may be arrive out of order also. Okay. So sometimes duplications also will be there. Okay. Next, TCP. So TCP is a reliable protocol. Why we are calling it a reliable protocol? Since it has a acknowledgement, it provides an acknowledgement, right? So that it is called as a reliable protocol. Stream oriented, that is stream connection oriented and a reliable transport protocol. Okay. So actually, flow control versus congestion control. Flow control involves actually what is flow. Differentiate. You know the difference between flow control and congestion control. Both are totally different. Actually, flow control means it is preventing sender from overrunning the capacity of the receiver. Okay, preventing sender from overrunning. That is beyond the capacity. It cannot send the data. Right, the sender side and the receiver side, both the side, the speed should be matched. Then only they can able to follow. Right. So the sender is sending too much, that is too fast to send the data, but the receiver is not able to cooperate at the speed of the sender side means. So all the data will be, it may be delayed and some of the packets will be lost, right? So the side, the flow should be controlled at the sender side and the receiver side. It should be equalized. Then only the data can be received smoothly. Okay. So congestion control. Congestion control means that is preventing too much of data being injected into the network. Okay, beyond the capacity. Okay, capacity of suppose, for example, the bandwidth of that is network communication medium size is 100 kb means if you are injecting the data 150 or 110 means it's very difficult, right? So many data may be lost, right? So congestion control means it involves preventing too much of data from being injected into the network, thereby causing switches or links become overloaded. Okay, so you should know the difference. Actually, TCP supports for flow control and congestion control, but in UDP, these two mechanisms are not there, flow control and congestion control. But in TCP, these both the features are available in this TCP. And next, stream delivery. So stream delivery means that is a stream oriented protocol. That is TCP, unlike UDP, it is a TCP is a stream oriented protocol. Okay, that is UDP adds its own header to chunk of data, which is called as a user datagram, and delivers to IP for transmission. But the process may deliver several chunks of data to the UDP. Okay, that is several chunks of data, that is called as in streams. At a time, it can transmit several that is chunks, that is partitions of data. Okay, several chunks of data, that is called stream delivery. So that is here in this diagram you can see that, so sending process, receiving process, okay, process to process communication, stream of bytes of data are transmitted, stream of data is transmitted. Okay, sending and receiving buffers. Sending and the receiving process may not be necessarily write or read the data at the same rate. Just TCP needs buffer for storage. Okay, so that is, so what are the data? Sender is sending the data, the receiver has to store it in the buffer. At the same time, receiver, what are the data are sending by the receiver to sender, that also will be stored in the buffer. Okay, so if the buffer is full, only the data may be lost, right? So buffers are used in this TCP. So next, encapsulation. Okay, the TCP segment encapsulates the data received from the application layer. Okay, all the that is it encapsulates. You can see that. So data link layer payload. Next, payload means data. IP payload. After that, TCP payload. So finally, that is application layer. Okay. So in this diagram, we can see that is bulk amount. So large amount of data can be transmitted by using TCP. I told you, right? So TCP segments, that is application process is divided into number of bytes, right? The number of segments, right? So that is sent to the buffer, TCP sender buffer. So sender buffer send that one by segment, all the segments are transmitted through the communication medium, and that will be received by the received buffer. So receiver buffers the data and it transmits the data one by one. So that is an application layer. In the application layer, application process read the data from the byte by byte. That is segment by segment, it read the data. Okay. So this is the packet format of TCP. So first header, that is address is there. data, that is source address, destination address. So next, port address, source port address, destination port address. Next, sequence number, acknowledgement number. Next, header length, HLEN means header length. Then reserved for 6 bits, okay, free data. So what are the flags which is used here? That is the urgent flag. Any emergency data are there means the urgent flag will be set to 1. Otherwise, it will be set to 0. Then acknowledgement is set to 1 means, okay, and acknowledgement is there. So acknowledgement, push, okay, push, reset, synchronize, finish, okay, these are the flags are there. Then window size will be fixed here, okay. So what is the size of window? That will be fixed, kept it in this window size, and check some urgent pointer. Any emergency data is there means, okay, urgent pointer will be pointed to the data. Next, options and padding. Okay, so that here down you can see that all the flags are kept it here. That is urgent flag, acknowledgement flag, push, reset, synchronize, and terminate. Finish means terminate. Okay. Okay, that's all about TCP and UDP. So more or less that is a difference between TCP and UDP means actually UDP mainly used for small amount of data, TCP mainly used for large amount of data, and the UDP it won't provide acknowledgement, TCP provide acknowledgement, so that it is we can say that secured communication data in TCP. We can't say that it is not in UDP, it won't be actually secured communication. And connection less oriented protocol is used in the UDP, but the TCP you can say that connection oriented protocol. Okay, and multimedia streaming and the multimedia multicasting and all we can use UDP. Okay. Okay, so that's all about today's topic. So today's topic we have discussed about transport layer and 2 types of protocols, UDP and TCP. Okay, so first we have discussed in detail about the transport layer, then UDP and TCP. Now just we will discuss about 10 questions. We can see that. So can you say the answer of first question? Anyone? So this is the question. So this is the option. Okay. So question actually UDP header port number. Next Ethernet MAC address, IPv6 next header, TCP header sequence number. So these are the options. Yes, anyone can you say the answer? Which option will be the correct answer?
UDP port number is 16 bits, ma'am.
Okay, that's what I'm. Which option is the correct answer? Option A or option B or option C, option D? Anyone? Yeah, UDP header port number.
Question once again, ma'am. Question.
Yeah, question. Okay. So UDP header port number actually. Actually, port address is address size, port ID address. I told you right in the class. What's the size of port address? I told you in the class before. That is first it's what is port ID, then what is the size of port ID, then I told you the 3 categories, that is the range, right? So from that itself you can say the answer. UDP header port ID. Okay, you may forgot, I think, when a port address size is 16 bit. Okay, port address size is 16 bit. So the answer is option C is the correct answer. That is P. That is fourth one. Okay, P fourth one. That is fourth one is 16 bit. Okay, so remaining okay. First one is P4. That is UDP header port number equal to 16 bit. Okay, next. Q, Ethernet MAC address. Okay, So MAC address size is 48-bit, okay, that is available in the data link layer. IPv6 address, okay, next header, IPv6 version 4 and version 6 both will be there. Version 6 actually 32-bit, okay. Okay, option C is the correct answer.
Where is?
Yes, ma'am.
Yes, ma'am. Correct, ma'am.
Okay, okay, okay. Next question, ma'am. So can you say the answer? TCP connections are full duplex. TCP has no option for selective acknowledgements. All these questions are taken from the gate questions only. It will be very useful to you.
Option
Okay,
1
here,
and 3 are correct.
okay, option not 1 and 3. 1 only. 1 and 3. Okay, okay. 1 and 3 are correct. Okay, okay. Not 1 and 3. 1 is correct. Okay. Option 1, TCP connections are full duplex. Option A only is the correct answer because the transport layer TCP connections are only full duplex only. Okay, you know about simplex, duplex, and all, right? So TCP has no option for selective acknowledgement. Okay, that and all in our will come under the topic flow control. Okay, option A, that is only one is correct. That is TCP connections are full duplex. Okay. One and 3. Okay, TCP connections are message. Yeah, message streams. Okay, the third also is correct only. Correct only. You are right. Okay. TCP connections are full duplex and TCP connections are message streams only. Okay, you are correct. Good, very good. Next question. Third one. The transport layer protocol used for real-time multimedia file transfer, DNS, and email respectively, or first real-time multimedia. Immediately you have to remember that the multimedia,
UDP.
which protocol is used?
UDP.
Very good. Okay, then option UDP. Okay, and next file transfer. File transfer. Okay, TCP is also used for file transfer, right? Okay, next DNS. DNS email. DNS domain name system, that also for communication only, right? That UDP we are using, and email and all TCP we are using. Okay, so the first thing UDP, that is option C is the correct answer. Okay, that is mainly real time multimedia. Then TCP is used for what is the file transfer? Both it will be used. So option C is the correct answer. Next one, these questions. Transport layer aggregates the data from different applications into a single stream before passing it into which layer? It's very simple because that is that transport layer, which layer is available. Actually, transport layer, it receives the data from the network layer, right? That is, we can see that physical layer, data link layer, next network layer, next the transport layer. Okay, so it aggregates the data from different applications in a single stream before passing it to network layer. That is, answer A is the option A is the correct answer because from network layer only you get the message. It is also simple question. UDP is called connectionless because we have discussed about connectionless oriented and connection oriented, right?
Yes, ma'am.
Yeah, which answer is the correct answer?
UDP is connectionless oriented.
Which option is the correct answer? I told you that it can choose any path, right? Any path can be choose. The path won't be fixed
Option
for
A,
that particular. Yeah, option A, very good. Option A is the correct answer. All UDP packets are treated independently by transport layer. Okay, so that is the option A is the correct answer because it can choose any path. Okay, so sixth question, transmission control protocol. It is also the easiest question only. TCP. Which option is the correct answer? Option
A.
Option A. Option D, all the see it is connection oriented protocol. Transmission TCP is a connection oriented protocol, right? And three-way handshake to establish a connection. We have discussed in detail about the three-way handshake, establish connection and terminate connection, and receive data from the application as a single stream of data. You can transmit the data as in the form of stream, right? So all these options are all of you mentioned. D, option D is the correct answer. Okay, next one, seventh question. Which of the following is a version of UDP with congestion control? UDP means, okay, immediately you have to remember the datagram only. It is not stream, right? It is not a structured stream. Okay, so that is option A is the correct answer. So if it is TCP means you can say that stream control, but based on UDP, you can that is answer is
Datagram
control. Okay, next datagram control protocol. Next question, a dash is a TCP name for a transport service access point. Very simple. Out of this, port ID only we have discussed here, right? Port address. The port is a TCP name for transport service access point. By using a port address only in the transmission layer, we are accessing the data, right? That is port address. So transport service access point. Okay, by using this port address, we are answer option is A. Okay, port is a TCP name for transport service access point. Okay, next question. Transport layer protocol deals with. Yes, it is also such a simple question. So many times I told you in this class. Immediately you have to say the transport layer means
communication.
Process to process communication. Very good. Process to process communication. So the final question. Which of the following is a transport layer protocol? So out of these four, which one is the correct answer?
Stream control, ma'am.
Very good. Stream control transmission. It is also one of the feature of TCP, right? So stream control transmission protocol. Okay. So that is a correct answer. Very good. Okay. About today's class. So any queries?
No, ma'am.
Okay. So